Right, okay, so you drew this yesterday, correctamundo. You found the mean score of classwork and the mean final exam, yes? You plotted that as a coordinate, and then you drew a line going through that point and trying to do halfway in, like half the points above and below. Yeah, so your lines will all probably be a little bit different to each other, which is totally fine. Tamia just said, what?
Why would our lines be different?
Because Natalie may have chosen to go a little bit higher or lower than yours, because the only criteria is it has to go through the mean point. Now, I would hope that they would all be of a similar like gradient and intercept, but they don't have to be exactly the same. Yes? So it says find the equation of the regression line. So this is where you have to remember about equations of straight lines. So you've drawn a straight line. Straight lines have which format?
Y equals C.
Y equals mx plus c. And what do these m and c tell us?
C is the y-intercept.
Nice. So you're gonna, and m is the gradient, tres bien. So you're gonna look at your graph and tell me where does it cross the y-axis. Okay, so you're gonna establish where does yours cross the y-axis using your scale as accurately as you can.
Do you when you're actually just drawing a line, can you just stop it at like the two max and min values, or do you have to just sort of draw a large one just going through all the things?
I get what you mean.
So does your data look like this?
Yeah, like should it just go?
So you need to make sure you're going to the y-intercept.
So you can't go through the 0, 0? You can't go through the origin? You can't stop the line.
No, definitely not, because, well, I apologize, not definitely not. It's, you need to make sure you're going through the mean point, and then, like, so if your data looks like this, you're going to go through here. If your data took you to go through the 0, 0, that's fine, but you're not going to have something that does this just to go through 0, 0. Does that make sense?
So what happens if it goes like...
So it can go in, what do you mean minus?
Like if I go straight through, it takes me through the x down into the negative.
That's fine. That's fine. Huh.
It's a bit complex for me.
I know. I would hope that in an exam that it wouldn't go into the negatives. Does everyone's go into the negatives? Oh, that's a bit of a bottom, isn't it?
Yeah, I think my line might be a bit skewed.
Oh.
But it went through the mean point. It did.
And did it go kind of in the middle of all the others?
Yeah, somewhat. Yeah. Yeah, it was like, why makes the bottom? It says -5. You see what this says? If I went up to 10. That's not bad. It's
that's good.
It's like 0, 0. Yeah,
but that's fine. If it goes to 0, 0, naturally, I just didn't want you to do this and make it go through 0, 0. Now, to be honest, what are we talking about? Classwork and final. Well, see, it doesn't necessarily mean that if you get 0 in your classwork, you're going to get 0 in your final. Like, correct, you can't. I hear you, sister. But if you put it through 0, 0, does that make everything go askew?
That's a cool word.
Askew. So maybe just use a bit of noggin when you're doing these.
What's this?
What do you mean? What's this? No, because we haven't discussed this before. So I'm saying, moving forward, use your noggin when you're doing this and think, hang on a minute. It has to cross the y-axis, because I need to know my equation of my line. And perhaps it would start at 0, 0. If not, don't worry. Like, don't do these ones where to make it go through
But
zero.
then what happens when it crosses to the x-axis?
No, that's fine. Okay, it can cross the x-axis because that's no bearing on our equation. Okay, the important thing is this one here.
No, but like what I'm saying is it's like a positive gradient and it goes through like the x-axis.
That's it, starts with the gradient.
Yeah.
If it goes down to the negative, that's fine.
Yeah.
In an exam, they will probably either give you the axes if that's the case, or tell you to go. Often they'll say use 1 centimeter to represent 500 and go from this to this. So they will encourage you to do into the negatives. Yes. Yeah.
Right. A score.
Okay. So we're all good with that.
Yep.
Yes. So obviously, once you've found your y-intercept, so we've decided ours is 0, 0. You then need to find your gradient. How would you find the gradient? Yeah, a few people are kind of saying rise over run, and then Cree's saying put your x value and y value in. So I would suggest that there's quite a lot of action going on here, but you do know it goes through the mean point, yes?
Yeah.
And because we've said it goes through 0, 0, that's going to be a good help for us to find our gradient. Because our rise is going to be whatever our y mean was, yes?
Yeah.
And our run is going to be whatever the x bar was. So you're going to do this value divided by this one, your rise over your run, and that's going to be your gradient. Now that's only particularly helpful for this one because it went through 0, 0. If not, then you just measure.
So you can also use the mean point.
You can use the mean point. So you're just going to find something on your line to enable you to find the rise and the run. Make sure that when I say measure, make sure that you are looking at your scale as well. So if you've gone up 1 square, check that that's 200 people, whatever. It doesn't matter. But make sure you're looking at your scale when you're doing your rise over run.
Is there a thing or to define this if you don't?
So for these ones, so going through the mean point, no. For the linear regression, which is the next, the least squares regression, yes, there's a special thing on the calc. So our one is going to be just y equals something x. So does anyone want to hook us up with the something? 0.96? So it then says use the equation of regression line to estimate Caroline's score for the final exam. Now it's an estimate because this equation is not perfect. What do we do?
Can we just measure that on the line? The area over the
Well, you could, but we've found an equation for it, haven't we?
Yeah.
So what does our equation say? So mx.
Oh, yeah.
So we've got y equals 0.96x. What are these y and x's? What do our y and x's represent?
So
this is the final, yes? And this was the classwork. Do we know Caroline's classwork?
yes.
Yes? Oh, are you following me?
Yeah.
So what are we going to do then to find Caroline's? You're going to multiply it by, so you can do 0.96 multiplied by 80. Yes? Are we good?
Yes.
So, sorry, what was that? 76.8 Tresbians. Right. Are we all comfortable with that shenanigans? Yes?
Yeah.
What's this bad boy say? So a study was done to investigate the relationship between age in years of a young person and the time in minutes on which a child can run 1 kilometre. Data from children between ages of 7 and 18 was collected. The equation of the regression line was found to be blah. Interpret the slope and the y-intercept. Okay, so these questions sometimes send people into a bit of a tailspin, and they start telling me that it means gradient and y-intercept. But slope doesn't mean gradient. What they're asking you to do is to interpret it. Do you understand what the difference? So what they're saying is that what does our gradient tell us about this particular situation? So what is the slope or gradient for this particular question? -1/2. Okay, so our slope, I'm just going to say simple. So our slope is -1/2. What does that actually mean for this particular question? Careful, it's -1/2. Well, let's imagine, what does this graph look like? So let's have a little picture in our heads. So what does it look like? It starts at, don't all shout. Starts at 20, yes? You all happy with that?
Yeah.
And it's got a gradient of -1/2. So we know it's going downhill. What's this axis talking about? Which is this axis? Which is, what's it represent? So tell me, it represents, Katie, sorry? The age of the children, yes? Yes, you're with me?
Mm-hmm.
And what did this axis represent?
The number of children.
No.
The time.
Yes?
Yes.
Information's up there, yes? Okay, so the time in which they can run 1 kilometre. So, tell me, what does this show us? It tells us that as a child gets older,
It
takes them less time to run the race. Yes? So, the slope is telling us that information. It's helping us determine that as a child gets older, the time that they take to run it is getting less. Yes? It's, in other words, it's saying that for each year that a child gets older, what happens to the time taken? It's well, actually, no, we're going to have, but anyway, it's decreasing. Yes, does that make sense? So sometimes sketching it will help as well. What does the y-intercept what do we interpret by the y-intercept? I mean, realistically, it says,
6 when they're 7, it takes 7. 20 minutes.
yes, so when they're 7 years old, it takes them 20 minutes to run the race. Yes? We all good with that?
Yeah.
So do you recognise what the interpret bit means, though?
Yeah.
So you're not just saying what they are. You're not identifying. You don't say the y-intercept is 20 and the slope is -1/2. I'm awesome. Next question. Okay. You actually have to interpret it. You have to say, what does that actually mean for this particular question? Yeah. So it's just, and it's the way that some questions are. They're moving towards these kinds of questions a little bit more, which is what people don't like as much, understandably. Similar thing for this one. So we've got a new thing here, new equation of regression. It actually says here, state the gradient and y-intercept. So we do have to state them, and we also have to interpret them. Okay, so if you had a question like this, I would hope that you wouldn't just state what they were and think that you had done your job. I would understand if you had just seen this top one, you might have thought you'd done it, but because they've said state it and interpret, that obviously means you're doing different things. So I'll give you a moment and you can tell me. Right.
Can I show you my interpretation? Yes.
Oh, go on then.
The grading tape, there's only one thing to do.
Well, I did say Bergie had to do it. So, Bergie, you can at least tell me what they are. You can state them.
The grading is 5 samples,
Mm-hmm.
and what intersects.
Good reading without glasses on. Yep, we're back. We're back to Molly. Excellent. And Mally, what's the interpretation?
So what it's saying is that as the number of birds per hectare increases, so trees. You had trees on the trees, the birds increase by that much every time.
So, are we happy that she did a quick 180 when Leah went, huh?
I said, is that so? Trees.
So, as the number of trees increase per hectare, then the number of birds is going to increase. And the number of trees, the number of birds are going to increase by a factor of 5.4 for each new tree. Yes? Are we good with those? No, you multiply the tree by 5.4. And the y-intercept, sure.
So with 0 trees per hectare, there are already 8 birds.
Yes. I mean, and let's be honest, I always feel that the y-intercept is always a little bit of a load of rubbish, really. But anyway, that's besides the point.
Maybe we should recommend these pizzas.
No, let's not. Okay. Least squares regression. Okay, should we look at this now? All right, so least squares regression. This is a fancy pants line of best fit, if you like. Your calculator does all the hard work for you, which we all love. This is just an explanation of how it finds it. What they're doing is they're looking at the distance away from a line and finding the least amount. But don't worry too much about it. You just do it in your GDC. So let's enter all of this information into your calcs. Right, once your data's in, oh, I don't know, I can't show you on here. I need to come over someone's shoulder. Right, so we go to the menu, is it menu?
Yeah.
Stats. And let's try stat calculation. Ah, yes. So then it says, see number 3 and number 4?
Yeah.
They're both very similar. You can use either of them, but you just have to recognize that one of them, oh, she's muted. One of them has your the gradient first, and then the y-intercept. One has the intercept and then the gradient after it.
Yeah.
Yes, so it's just in a different order. So I would suggest probably do 4.
Oh.
Oh no, we're not used to the other one. 3. You get good practice. So let's do 3. And then it says X list, Y list. So you choose wherever your lists were.
The X is the distance. Am I wrong? Girl?
X is your distance, yeah.
Yeah.
And then Y is the fair.
Do I include the categories? Or just press OK?
You can just press OK.
Okay. I think it's that one.
Right, so then, can you see that it's giving you a little summary of letters? It's got M, B, and then it's also got R. Yes, do you see that?
Yes.
So then your answer. What would your gradient? What would your M What would your equation be for this?
0.117 x plus 83.3 plus 82.
I think you're wrong. You put everyone else got the same. You haven't got something different. I'm guessing maybe you got something slightly different to everyone else. And remember, it's an equation, so it would be y equals or whatever. Yes. Do we get the idea?
Yes.
So once your data's in there, that's giving you, that's all you have to do. It's very exciting.
Amazing.
So use your GGC to sketch a scatter diagram of this. Oh, shush now. We'll write down the equation for the line of best fit. Check. Use your equation to estimate the cost of a 1,000-kilometer flight. What we're going to do then? Substitute 1,000 in there. Get an answer. The end.